Hi, my name is Florian from Quality Guru. I answer your questions and share knowledge about quality management. And today we'll talk about the production control plan. Production control plan is a tool how we can control in a manufacturing operation the quality of our production process and ensure that only good parts leave the production, and that if there's a problem, we automatically and immediately identify it and we can stop the problem as soon as possible, and by this ensure a high customer satisfaction and minimize the cost and the amount of problems we face in our own processes. If you get value out of these videos, I would be happy if you could like and subscribe for this channel, and like this you get notified whenever there is a new video coming out. The production control plan is a very basic quality planning tool and a quality control tool, which helps us to really control what is going on in our production process and identify all the problems immediately and stop them as soon as possible before they leave our company. And here I show you a basic template for a quality control plan or production control plan, where you can see basically there's a header where you can fill out a lot of information specific for the project, what you're dealing with. But what I would like to show you now is how to fill in such a control plan and what is the basic logic behind. Because first of all, we start with the production process, and there we normally have a process flow. A process flow means when I produce something, I do first step 1, then step 2, then step 3, then step 4, and it's a sequence of different activities, one after another, in order to produce the product which I want to produce at the end. So there are several activities involved, and in each of these activities basically something can go wrong, and maybe we identify this in our FMEA, in our failure mode and effect analysis. If you don't know what that is, check out my video about FMEA. There you can learn what it is, and then we can identify where we have the risk and take over the controls we identify into our control plan. And this will be the tool. This will be the recipe, the list of tasks. If I do them every day, if I do them all the time in the correct order like they're defined, then in theory I should not ship any part out of my factory which has a defect or problem. I should identify them first and control the situation immediately. So let's take an example. Maybe you know Lego, the favorite or this family toy for children. These colored little pieces, you can build houses with them and all kinds of things. I think almost everybody knows them probably. So these are very simple stones, and they get normally produced by a plastic injection molding process. So you have these huge injection molding machines. You have a tool which opens and closes, and the hot plastic gets injected into them. The part, there are little cavities in the mold, they fill up in the right shape of the Lego stones. You can inject the material in different colors, red, blue, yellow, green, and they will fill up the cavities, they will cool down, they will stay in shape, and then the tool opens and basically the Lego stones will fall into a box or on a conveyor or however it is organized in their factories. I've never seen it, but this is basically how they are produced. Injection molding and tools open closing, and then they will be getting packaged into boxes probably and then shipped into all the stores where you can buy them. So let's see, I make a very simple control plan for this. So we have the injection molding process on an injection molding machine. I call the injection molding machine 1, 2, 3. It has a number. Maybe in your company you also have machines with numbers. And then there's a packaging process where we put, where there's a packaging machine, and the packaging machine has the job to always put 100 pieces into one box. Okay, very simple process. So let's now see how it works out in the control plan. And there are many templates out there. If you like this one, you can use it, but there are many templates out there and they're for free. You can use them for your own company, and maybe your company has your own one which is similar and maybe not exactly the same, but the principles are the same. The target is how to control my process and what to do when something goes wrong. So we see the injection molding machines. There's 3 steps. We have product characteristics and process characteristics. So we can first identify what do I have to ensure in this step on the product level and on the process level. So that means the process is the injection molding process and the product is what is coming out. So I can do some checks and some controls on the product, and I can also do some checks on the process. Why should I do checks on the process? Because if the process is not in the condition what it should be, it will not give me the outcome what I want to have. So I also need to check the process. It is a preventive approach of quality control. So here let's see, what do I have on the product level? I have the dimension. So here I could say the dimension of the stone should be 50 millimeter plus minus 0.02. So there is a certain tolerance on the dimension. It can be a little bit smaller, a little bit bigger, but it cannot be too deviated, because then they would not fit together and they would not look nicely when they're built together. They would be all in different shapes and forms, and this would not be the quality the customer wants, and they will complain about that something is wrong. So I need to make sure that the dimension is in the right size. So here I can use, for example, I take a caliper. Caliper is probably way too rough for this small dimension, but we can say, okay, for the sake, maybe you have more sophisticated measurement equipment to measure this. Maybe you have gauges, specific gauges for this, could be. But let's say here we have a caliper, which is a measurement device where we can take dimensions from. And here we say, okay, what is the sample size? How often should we do this? We should take 5 pieces every hour. And who should do this? The quality inspector. And the control method is sampling, because I don't check all the parts. I check only 5 pieces every hour. And I believe if my process is stable, then also 5 pieces every hour should give me enough information about the situation of the quality of the part. And I can see the stability. And I can also see what is my reaction plan. So what is, if I find that the dimension is getting bigger or smaller, because the injection molding process has some changes maybe, then I should stop and adjust the process. So I stop the process, I go back to the machine, I adjust, I make sure that parts coming out which are in specification. And if I cannot do this, then I should ask my supervisor, my boss, and escalate the topic basically in the organization, so to ask for some support on the problem solving. And I should also contain the material, because if I have 1 hour a good result, the next hour a good result, but then 1 hour later a not good result, so the parts are rejected, then I need to go backwards and check all the parts in order to see if there is a problem and when did the problem start, and take all the parts out of the process which are not qualified for my customer. So here, this is the basic logic. We can do the same with the weight on the part. So we could say, okay, the weight, I didn't put a number here, but we could say, okay, 5 grams plus minus 0.05 grams or something like this. So the weight of the part should not be too high, should not be too low, because then maybe the filling of the part is incorrect, and that could also cause some problems. So we could say, okay, every day we should sample 10 pieces on a scale and measure them. Could be a method. I just want to keep it simple and give you an example, so that here the reaction plan would also stop and adjust the process, contain the material, go backwards and find when there was a change, take all the bad material out of the process and make sure that they're not shipped to the customer. And then we also have on the process level, we have pressure, for example, injection process, pressure of 100 megapascal, for example, in this example, and it should be in this range of 99 to 101. And I can look on the control panel of the machine once per shift with a visual check to see if I'm really keeping this pressure. If not, I need to stop the process, adjust the process. So there are many ways I can do this. I can put there a lot of details, and in reality there will be probably more checks or maybe even more sophisticated checks, but this could be a very simple plan how to control injection molding process. I have here an example on the packaging as well. So we want to have the packaging machine always putting 100 pieces into the box. How can we do this? We could, every shift, we could open a box and we could count them 1 to 100, or maybe we have a counting machine or something like this. Or we could weight them and then say, okay, 1 piece is 5 grams, so 100 should be 500 grams. So All these kind of controls we can build into the process in order to ensure that our process is doing what it should do and that our product looks like it should be, it's meeting the requirements, and we're not shipping any bad parts out to our customer. And like this, we ensure customer satisfaction, perfect production control, and the quality will be good, the customer will be happy, and the company will be all right. So let me know your experience about quality production control plan in your company, in your own experience. Are you working with it? Are you having any difficulties? Let me know. I would like to answer your questions. And please, if you like these videos, hit like and subscribe so that you get informed when there is another video. Thank you and see you in the next one.